Welcome to the deep dive. Today we're really getting into the weeds, looking at a helicopter flying handbook.
Yeah, specifically the advanced stuff, not your everyday flying.
Exactly. We're
Yeah.
going beyond the basics, looking at, the really demanding techniques pilots need for tough environments, maneuvers that push things right to the edge.
Right. And our mission, so to speak, is to pull out the core ideas. What does it really take? The skill, the planning, the precision involved.
And it's stressed right up front, isn't it? These aren't casual joyrides.
Absolutely not. They demand serious skill. And there's this fundamental rule hammered home in the source. If you have any doubt at all about whether you can pull off a maneuver safely,
You abort.
you abort the mission. Simple as that. Safety first.
If in doubt, abort. That definitely sets the tone. So what specific challenges are we digging into?
Well, we'll start with reconnaissance, how pilots check out unknown landing zones. Then look at tricky takeoffs like when power's low or space is tight. Then stopping fast, the rapid deceleration. And finally, operating in really tough terrain. Landings on slopes, in confined areas, and even on isolated pinnacles or ridgelines.
Got it. So let's kick off with reconnaissance. Landing somewhere new. You can't just, drop in blind, can you?
Definitely not. Reconnaissance is absolutely crucial. It's all about gathering info before you commit.
So first up is the high reconnaissance. What's the goal there?
This is your initial overview. You're flying maybe 300 to 500 feet above the site. You're trying to suss out the wind, pick a likely touchdown spot, see if the area itself is suitable, size, slope.
And obstacles approach paths.
Exactly. Spotting major obstacles, figuring out your best way in and out, and critically, identifying potential spots for a forced landing if the engine quits early in the approach.
So high enough for a good view, but also high enough to have options if things go south.
Precisely. You need that altitude buffer for an engine-out glide into the wind while still being able to really study the area. The handbook suggests about a 45-degree angle works well from that height for judging barrier heights, area size, that kind of thing.
Makes sense. Get the big picture first. Then there's the low reconnaissance.
Right. This happens as you're actually descending on the approach. Now you're closer, verifying what you thought you saw from higher up.
Looking for the details you miss.
Yeah, exactly. The things that are hard to spot from altitude, like wires are a classic one. Small dips, uneven ground, maybe mud or soft sand. Things that could ruin your day on touchdown.
Ah, the fine print.
That's a good way to put it. And this low pass leads to a really critical decision.
Land or go around.
Yes. And that decision has to be made before you slow down below effective translational lift ETL or before you drop below the height of any surrounding barriers.
Why is that point, ETL and barrier height, so vital?
Well, below ETL, your rotor isn't as efficient. You need more power just to hang there.
Mm-hmm.
And if you're below the barriers, your escape route is gone. You're committed to that spot. If something goes wrong, then
You're trapped.
pretty much. Very few good options left. High risk.
Okay, so if the decision is to land, what happens next? Direct to the ground.
You could, if it looks perfect. But more often, especially in tricky spots, you'll transition to a hover first. A really precise hover just above the intended spot.
Why hover first?
It lets you get a final close-up look, really inspect that touchdown zone for anything nasty hiding there before you actually put the weight down.
And even once you're down, still not time to relax.
Yep. Keep the rotor RPM up until you physically felt the helicopter settle and checked it's stable. Make sure it's not going to suddenly tip or slide out from under you.
Got it. And ground reconnaissance. That's before takeoff.
Yes, that's planning your departure after you've landed in a challenging spot. You get out, walk around if possible, analyze the area from ground level, figure out the absolute safest path out, spot any low-level hazards, especially for the tail rotor or skids, and plan exactly how you'll taxi or hover from where you are to your takeoff point.
So planning before you go in, planning before you come out. Okay, reconnaissance covered. Let's talk takeoffs. What if a simple vertical lift just isn't on the cards? Say, tight clearing, tall trees all around.
That sounds like a maximum performance takeoff situation.
Yeah.
The whole point is to climb out as steeply as possible to clear those barriers quickly from a small space.
What's the absolute must-have for that?
Power. Specifically, enough power available to hover out of ground effect OGE for the current conditions. You have to verify this, usually with a hover power check.
Why OGE power?
Because if you only have enough power to hover in ground effect, the moment you climb out of that cushion, you might start sinking again. If you don't have OGE power, attempting this, asking for trouble.
And the climb angle you actually achieve depends on conditions, right? Even if you give it everything.
Absolutely. High density altitude, no wind. heavy weight, all those things will result in a shallower actual climb, even with max effort. Physics dictates the outcome.
Sounds like you're operating right on the edge.
You are. The source points out that, especially with little wind, this maneuver often puts you right into the avoid zone on the height velocity diagram.
The dead man's curve.
Exactly. Low altitude, low airspeed.
Hmm.
An engine failure there requires exceptional skill to handle safely.
So how's it done? Take us through the technique.
Okay, usually you position yourself at the most downwind edge of the clearing, gives you maximum room. Bring the helicopter light on the skids, just enough collective so most weight is off, but you're not airborne yet. Hold it steady. Then, smoothly but firmly, increase collective to max available power.
Coordinated controls, I assume?
Oh yeah. You need just enough forward cyclic to set that steep climb angle and pedals to keep it straight. Main focus. Maintaining that steep angle and critically maximum rotor RPM. Keep that configuration until you're clear of the obstacle, then ease off into a normal climb.
What about that purely vertical takeoff variant?
Right, that's for when there's literally zero room to move forward. The idea is, if you find you don't have the power to clear vertically, you can just lower collective and settle back down.
But the downside?
You spend even more time in that dangerous height velocity avoid area.
Yeah.
And it absolutely demands OGE hover power, no question.
What are the common mistakes pilots make here?
Number one is probably not checking the performance data beforehand, just assuming you have the power. Another big one is nosing over too soon, trying to get airspeed before you're clear. Got to climb first. Also letting the RPM droop, that's critical. And jerky, abrupt control movements. Smoothness is key.
Okay, different scenario. What if you're so heavy or the air's so thin you can't even hover properly, even in ground effect?
That's when you need a running takeoff or rolling takeoff for wheeled helicopters.
Yeah.
Use forward motion to generate lift.
So like an airplane takeoff almost.
Sort of, conceptually.
Mm.
You're using forward speed to get translational lift working for you. But there's a key requirement. You must have enough power to at least momentarily lift the helicopter off the surface. If you can't even get light on the skids, the handbook says it's unpredictable and unsafe.
And you need a decent surface, obviously.
Definitely. Long enough, smooth enough, clear path ahead. Technique involves lining up, getting light on the gear, then smooth forward cyclic and collective increase to start rolling.
And keeping it straight is vital.
Absolutely critical. You have to maintain alignment between your heading and your ground track. If one skid or wheel catches while you're light and moving, and you have any sideways drift or control input?
Dynamic rollover.
Exactly. It can happen incredibly fast. You counteract it by keeping aligned, maybe even a touch of cyclic, into the direction of movement if needed.
Okay, so you're rolling, accelerating, fighting rollover. Then what?
You accelerate through ETL while still on or very near the ground. The helicopter lifts off fairly level, already moving. You then keep it low, maybe stay in ground effect initially, building up airspeed towards your normal climb speed.
Sure.
Once you have that safe speed buffer, then you transition to a climb profile, staying clear of HV diagram hazards.
Sounds like if you need this maneuver, you're really pushing the aircraft's limits.
The handbook is pretty clear. For most modern helicopters, needing a running takeoff usually means you're at or very near, possibly even over, the maximum allowable weight for those conditions. It's not a standard procedure. It's driven by necessity.
Common errors on this one.
Not keeping it aligned, leading to rollover risk. Trying to lift off too soon before getting proper ETL. Too much forward cyclic while still rolling can damage the gear. Dipping the nose too much right after liftoff and settling back down. And climbing out too soon, not building enough airspeed low down first.
Okay, we've covered getting airborne under duress. What about the flip side, needing to stop very quickly from forward flight?
The rapid deceleration or quick stop. Yeah, that's a vital skill. Aborting takeoffs, dodging unexpected obstacles, transitioning from fast-forward flight to a hover.
How do you manage that sudden stop without losing control?
It takes really good coordination. You practice it at a safe altitude, maybe 25, 40 feet, something that guarantees tail clearance, and you end up in a stable hover. And crucially, you do it while staying out of the hazardous parts of the height velocity diagram.
Walk me through the control inputs. It sounds tricky.
Okay, you start it with aft cyclic. That begins slowing you down.
Yeah.
But as you pull back, the helicopter wants to climb, right?
Right.
So at the same time, you apply aft cyclic, you smoothly lower the collective. This counters the climb. It's a simultaneous coordinated action. Too much aft cyclic, you balloon up. Too much collective down, you drop like a rock.
And pedals, throttle.
Yep. As collective comes down, torque reduces, so you need right pedal to maintain heading. and you adjust the throttle to keep that rotor RPM steady.
You mentioned the nose pitches up. Is there a limit?
Oh, absolutely. You have to be careful not to pull back too aggressively. Excessive nose-high attitude puts a lot of G-load on the rotor, and in extreme cases could even risk a rotor stall. It's a learned visual limit for your aircraft.
So aft cyclic, lower collective, pedals, throttle. Then how do you level out into the hover?
As you feel the forward speed bleeding off and you're nearing zero ground speed, you smoothly transition. Lower the nose back towards level, maybe descend slightly to your target hover height, and then increase collective as needed to arrest the remaining forward motion and establish that stable hover. Fine-tune with all controls. Think of it like rotating around the tail rotor hub.
What are the classic ways pilots mess this up?
Common one is lowering collective first, without the aft cyclic that just makes you fall. Ballooning up from too much aft cyclic too quickly, not controlling the deceleration smoothly, ending up stopped but still tail low, letting the RPM decay, huge error. Also, waiting too long to bring the power back in during the recovery, risking an overtorque, not having enough ground clearance, using pedals incorrectly, and of course that excessive nose-high pitch.
Definitely requires finesse under pressure. Okay, let's switch gears to approaches. Normal glide path isn't always an option.
Right. Sometimes obstacles or the landing zone itself force you into either a steep approach or, at the other extreme, a shallow approach leading to a running landing.
Steep approach first. When is that the go-to?
When you've got high obstacles on the approach path that a normal angle won't clear, or if you're going into a really tight confined area, also sometimes used near pinnacles or cliffs to cut through turbulence quickly, the descent angle is much steeper. Think 13 to 15 degrees.
Sounds like it could get dicey. Is there a particular big hazard with steep descents?
Yes, the absolute main one is vortex ring state or settling with power. Huge danger here.
Explain that again.
It happens when you have a combination of factors. Significant power applied, very low airspeed, usually under 10 knots, and a high rate of descent, over 300 feet per minute. If you get into that situation, the air flowing down through the rotor disc gets disrupted. You lose lift dramatically, control gets mushy, and you can get into an uncontrollable descent rate. Very bad news, especially low down.
So avoiding that box is paramount. How is the technique managed?
You have to be really precise. Maintain your track exactly toward the touchdown spot into wind if possible. You use a good amount of collective reduction to establish that steep angle. Then slight aft cyclic controls your deceleration down that path. Collective becomes your main tool for adjusting the angle and rate of descent, while cyclic fine-tunes the closure rate. Pedals keep you trimmed.
What if the landing spot disappears under the nose on such a steep angle? How do you stay on track?
Good question. That takes practice. You learn to use other visual cues on the ground, things parallel to your intended path, to judge your alignment and descent profile. You're looking at relative motion.
And what about ETL on a steep approach?
You lose it much higher up than usual.
Yeah.
So you need to anticipate that. As you slow down near the bottom, you'll need to bring in collective earlier and maybe more firmly to arrest the descent rate, and possibly use a bit more forward cyclic to keep moving towards the spot as the translational lift disappears. The goal is to arrive precisely over the spot in a stable hover, maybe 3 feet up, zero speed.
And wind inside confined areas.
Right, as you drop below tree lines or buildings, any wind you had helping you might suddenly vanish. That can cause you to settle unexpectedly fast. Got to be ready with that collective.
Common errors for steep approaches.
Low RPM, always bad. Using collective incorrectly for the angle, not compensating for collective changes with pedals, slowing down too much trying to stay on the angle risks VRS, not recognizing ETL loss and adding power too late, not arriving at the hover height, speed, and attitude altogether, too much aft cyclic near the ground tail strike risk, and letting the gear get misaligned before ETL loss rollover risk.
Okay, steep covered. Now, the shallow approach and running or roll-on landing, what is this used?
This is for when you just don't have the power to hover safely. High density altitude, heavy weight. Instead of stopping to a hover, which you can't do, you land while still moving forward, using translational lift all the way to the ground.
So, touchdown with forward speed.
Exactly. The angle is much shallower, maybe 3 to 5 degrees, like an airplane ILS approach. And just like the running takeoff, it demands a long, smooth, clear surface and perfect alignment of the landing gear with the direction of travel to prevent dynamic rollover.
How do you control speed and descent on that shallow path?
You start like a normal approach, but reduce collective less because the angle is shallower. You keep your airspeed up initially, then gently slow with aft cyclic as you get closer.
Yeah.
Coordinate everything. Collective manages descent rate angle. Cyclic manages speed and track. Aim to touch down at or just above ETL speed.
And the touchdown itself.
Level attitude just before touchdown. Cushion it with a little collective right at contact, of pedals for heading. Once down, maybe slight forward cyclic for blade clearance. Use cyclic to stay straight, maybe lower collective a bit for braking.
Now, there's that big warning about what not to do after touchdown.
Yes, super important. If the helicopter stops suddenly on the ground, maybe you lowered collective too fast, hit a bump out, the nose can pitch forward hard. The absolute DO not is yanking back on the cyclic to stop the pitch.
Why not? Seems intuitive.
Because you risk the main rotor blades flexing down and hitting the tail boom, or even damaging the transmission mounts. It's a catastrophic failure potential. For wheeled helicopters, you use brakes to stop, not aft cyclic.
Wow. That really highlights how critical specific procedures are at the limits. Counterintuitive reactions can be deadly.
It does. Understanding the physics and the machine's limits is everything.
Common pitfalls for the shallow running landing.
Getting too nose high near the ground, not using enough collective to cushion hard landing, poor heading control, drifting sideways rollover risk, letting the speed decay too much before touchdown, losing the ETL benefit, touching down too fast, wrong attitude at touchdown, low RPM, bad alignment, all recipes for trouble.
Okay, we've covered assessing, taking off, stopping, approaching. Now let's get on to the really specific terrain challenges. Slopes, confined areas, pinnacles.
Right, each of these brings its own unique hazards and demands specific techniques.
Slopes first. What are the big dangers?
Dynamic rollover is number one. Mass bumping is another possibility if you use too much cyclic.
And the golden rule for landing on one?
Land across the slope. Never nose up or nose down the slope. Landing nose down puts the tail rotor way too close to the rising ground behind you.
Okay, across the slope, how does that work?
You approach across the slope into wind, ideally. Establish a hover, positioned laterally over your spot. Slowly lower collective. The upslope skid touches first. Pause. Then apply gentle lateral cyclic into the slope uphill.
Okay, cyclic into the slope.
Right. That holds the upslope skid there while you continue lowering the downslope skid by slowly reducing collective further. As the downslope skid comes down, keep adjusting that lateral cyclic into the slope just enough to stop any sliding.
Is there a limit to the slope angle?
Definitely. Your aircraft flight manual is the final word. 5 degrees is a common training limit, but check your specific POH. If you feel weird vibrations or get mask bumping, that's the cyclic hitting it stops, you've reached the limit for that angle. Abort back to a hover immediately.
Once both skids are firmly down.
Collective fully down. Neutralize cyclic and pedals. But keep the RPM up until you are 100% sure it's stable and not sliding. Ready for an instant takeoff if needed. Maybe a little cyclic wiggle to check the ground firmness before reducing RPM.
And take off from the slope.
Basically the reverse. Max RPM, collective down. Cyclic into the slope initially. Slowly raise collective. The downslope skid lifts first. As it comes up, smoothly center the cyclic so the helicopter becomes level just as the cyclic hits the middle. Pause. Check stability just off the slope, then raise collective to climb away.
Key thing to avoid after lifting off.
Don't turn the tail into the slope. Easy way to get a tail strike. Climb clear first.
Common mistakes on slopes.
Ignoring wind. Low RPM. Bad heading control. Turning the tail uphill. Lowering the downslope skid too fast. Using way too much cyclic into the slope, causing mass bumping. Not adjusting cyclic correctly and sliding. Holding cyclic into the slope during the takeoff lift instead of centering it.
Right. Confined area operations. Sounds like the ultimate test.
They really are. Think small clearings, city streets, rooftops, anywhere obstructions limit your space. The pilot here is like part surveyor, part engineer, part manager, all at once.
Top priority in there.
Clearance, 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 clearance. Main rotor, sure, but especially the tail rotor. It's often hidden from view. And wires, always look for the poles. Wires are devilishly hard to see. Expect turbulence if there's wind. And always, always have identified potential forced landing spots and a clear out, a go-around path.
And you mentioned planning the takeoff before you even land.
Non-negotiable. You have to know the height of the obstacles and be certain you have the power margin to get back out before you go in. Takeoff usually needs more power than landing. Also, fix your departure heading, your azimuth, before you descend. Gives you a target if visibility is poor on the ground.
How does wind work in these tight spots?
If it's blowing 10 knots or more, expect effects. Updrafts on the windward side of barriers, downdrafts and swirl on the leeward side. Plan your approach around that, but be ready for surprises.
Approach technique?
Use wind and speed if you can, but keep those emergency options open. Descend no steeper than you absolutely need to clear the barriers, tail rotor, and hit your specific landing spot. Aim for a precise point, often well forward in the area, keep it in sight, don't turn the tail towards obstacles after hovering.
And take off.
Initially, it's altitude over airspeed. Clear the obstacles first. Figure out your takeoff type, probably max performance in your start point. You might need to hover sideways or backwards to get there, always checking that tail clearance.
How do you judge the climb angle needed?
Mentally draw a line from your helicopter's highest point up to the top of the tallest obstacle on your path. Fly that line. Power up to clear it. Confirm you're clear, then accelerate to climb speed before reducing power.
Common pitfalls for confined areas.
Skipping the recon, high or low. Wrong approach angle, low RPM. Not thinking about emergencies. Vague landing aim instead of specific spot. Ignoring wind turbulence. Bad takeoff technique. And the big one, hitting something. Usually the tail rotor.
Okay, last challenge, pinnacles and ridgelines. Landing on a tiny peak.
Yeah, feels exposed, pinnacles drops off all sides, ridgeline 1 or 2. Even without trees right there, the hazards are significant. Unpredictable wind, up-down drafts, turbulence, and often absolutely nowhere nearby to land if things go wrong.
How do you approach and land safely?
Try to climb up on the upwind side for lift. Approach parallel to the ridgeline into wind. Use a steeper approach, especially in wind, to minimize time in turbulent air near the edge.
Judging speed must be tough with no close references.
Extremely tough. You have to judge closure rate by how the landing zone itself changes size. The handbook says aim for it to look like you're approaching at a brisk walk. Definitely avoid the leeward side downdrafts and turbulence live there. When landing, use the long axis, touchdown forward. On rooftop pads, watch for people, structures, tail clearance, maybe hang the tail off the edge. Stability check is crucial before reducing RPM.
And taking off from there, what's the priority?
Here it shifts slightly. Airspeed over altitude initially. Getting speed quickly is more important.
Why speed first?
It gets you out of the low-slow danger zone faster, reduces time in the HV avoid area, and gives you much better glide distance and flare capability if the engine quits right after liftoff.
So accelerate horizontally before climbing steeply.
Exactly. Lift to a hover just above the surface, accelerate smoothly out of ground effect towards normal climb speed, then pitch up and climb away. Absolutely crucial. Never just dive off the edge down the slope after clearing it. Maintain altitude or climb.
Pitfalls for pinnacles and ridges.
Again, poor recon. Wrong approach angle or side for the wind. Low RPM. Not considering the lack of emergency options. Ignoring wind and turbulence. Failing to maintain altitude right after takeoff before speed builds. Bad closure rate judgment. Being too slow to get to climb speed.
Wow, quite a journey we've taken from scouting a field to perching on a peak.
It really covers the spectrum of advanced helicopter handling.
Yeah.
You see these common themes popping up again and again, don't you?
Definitely. Like the absolute bedrock importance of reconnaissance and planning, it's not optional.
Not at all. It's fundamental.
Oh.
And coupled with that is knowing your specific aircraft inside out, its performance, its limits, what the flight manual says about hover power, the HV diagram, slope limits.
And the actual flying, the control inputs.
Has to be incredibly precise, smooth, coordinated, almost second nature built through practice. And across nearly everything you talked about, maintaining proper rotor RPM. It's the heart of it all.
Having it out seems vital too.
Always. That escape route, the go-around option, the emergency landing area, constantly evaluating and maintaining those options is key risk management.
Plus constant awareness of what the environment is doing.
Exactly. Wind, turbulence, hidden hazards, surface conditions, slopes. You're constantly processing that interaction.
And those common errors you mentioned kept reappearing.
They do. Low RPM, poor coordination, ignoring data, misjudging conditions. They're often the root cause when things go wrong in these demanding situations. They highlight how crucial the fundamentals are.
It really emphasizes that this kind of flying isn't just stick and rudder work. It's a whole mental game.
That's it exactly. The pilot needs to be that surveyor, that engineer, that manager, making critical decisions under pressure, integrating everything.
So we explored this intense world of advanced helicopter maneuvers, from checking out unknown sites to landing on precarious slopes and peaks.
Yeah, it's a place where high skill, deep knowledge, and meticulous planning meet, often with very little room for error.
So maybe a final thought for you listening. What does it really mean to operate safely and effectively right at the edge of any system's capabilities? It could be a helicopter, it could be a complex project you're leading, maybe even pushing your own personal limits. How much deep planning, specific knowledge, and genuine readiness does it actually take to succeed, and crucially to do it safely when the margins are that tight?